All right, so in chapter 4, section 3, we're talking about natural exponential functions, so base e. And in the text, it talks about how to find the derivative. The derivative of e to the x is e to the x. So if we have something like this, e to the 6x, well, that would not be e to the 6x because it only works for that baby function, as I like to call them, e to the x, or e to the u is e to the u. We always have to multiply by the derivative of what we've substituted for. So this one would actually be 6e raised to the 6x, because we have to multiply by the derivative of that top piece. So in something like this, that would be similar. You could see the answer is negative 8e to the 2 minus 8x, because we have to take the derivative of what we're substituting. So that would be negative 8, and multiply that by our e to the u. Another one to look at is something like number 5. So if we let our u be x to the 7th, we would find our derivative. And I'll do a supplement probably for something like number 5. But again, it wants to find this equation of the tangent line. So once we find the slope generating function, the derivative, we would then plug in our value 1 to find the slope, and then the point 1e into the point slope form to find this equation that they have here. You can also do implicit differentiation. So if we have xy, again, that means if we're taking the derivative of this, we would have e to the xy times the derivative of that top piece. So that's our u, and so we'd have to do an implicit differentiation. And so I may add this one to the supplement. So 5 and 6, I'll show some supplements for. And then just looking at number 9, if this is an equation for the yield for an orchard at age t is this, at what rate, so that's the slope, is the yield changing at each of the following times. So once I find the derivative of this, I would plug in 5 and 10 and 25 to find that the rate of change, slope. So I will make a supplement for this one and add it to our sheet.